Yes. Okay. Right. We'll start. Today plan is to start unit 1 dimensions, but still we have some pending sections to be covered in units. Right. Okay. Hands up. How many of you received the tute's answer? How many of you got the tute's answer? Didn't get the tute's yet. Hands up. I didn't get the tute's yet. Uh, okay. But I posted your Dimension Institute and the file cover and logbook I posted. Uh, it should receive definitely this week. It should receive. If not, there is a problem. Uh, in that case, I will tell you what to be done. Don't worry. It should receive this week, definitely. Okay. Not only your tudes, 25 batch revision class also. Half of students got the tudes, but remaining half, I think I posted 25 revision tudes before I post your tudes, but still there's a small problem. Still 25 some revision students didn't get the tudes yet. There's a problem. Okay, right. Wait until tomorrow. Wait until tomorrow or Saturday. Uh, even you didn't receive them tomorrow or Saturday, then put a message. I know many of you put messages. I know that I saw the messages. Uh, but be patient only for tomorrow and Saturday, right? If you don't receive them, I will tell you, please visit your nearby post office and just check. I will share a registration number for each post. I will send a registration number, then go and check. But don't worry, be patient until tomorrow and day after tomorrow. Monday, put a message, sir, still I didn't receive the tudes. Okay, then I will tell you what you want to do. Therefore, it's okay. Sometimes this tube delay happens. That's very normal, so you don't think that much. For today's theory class also we'll manage it. We'll manage it. Okay. Right. Okay. Right. Last day. Right. What did we discuss last day? Still we are talking units, but today we want to start dimension section, but still we have some small section to be covered. We have some small sections to be covered. I think I explained already. We all learned 7 basic units. You must learn by heart these 7 basic units: mass, length, time, current, luminous intensity, amount of matter, temperature. Mass, length, time, temperature, current, luminous intensity, matter. You must learn by heart. Mass, SI unit is simple kg, length SI unit meter, time simple S seconds, temperature capital K Kelvin, current capital A ampere, luminous intensity candela simple C simple D, amount of matter simple M simple O simple L mole, amount of matter mole, amount of matter mole, right? Okay. Amount of matter mole, MOL mole. Addition to that, we talked about supplementary. There are 2 supplementary units. Supplementary 2 units. One is plane angle, other one is solid angle. Plane angle, we are very familiar. In our O-level maths, all the angles that we learn are belongs to plane angle. So therefore, you have a good understanding about plane angle. What is the SI unit measure plane angle? uh, radian. But you are very familiar with the unit called degrees to measure the angle, but the SI unit to measure the plane angle is radian. And in solid angle, we are using a unit called steradian. 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 Then what is based on basic units and supplementary units, we derived a set of units we called as, by the name itself, derived units. By the name itself, we learned it is derived units. Derived units. What is derived units? Basically, when the units which derived from basic and supplementary, we called as derived. How many derived units are there? There are many. We can't remember them. But what have we done for our convenience? We divided derived units into two different categories. The one category is, we all can remember, derived units with special names. I think we learned that part. Derived units with special name, we learned special names. The last category is derived units which does not have any special name. That means compound names. Derived units with special name. Other one is derived units with compound name. Compound name. Compound. I think I didn't discuss any examples for this scenario. I didn't discuss an example of the scenario. I think I didn't discuss. But we covered special name story. We covered this part. I didn't discuss that much. And then I went to the last two sections: multiples of units and submultiples of units. That story I'm not going to explain. Now we are very familiar. What is multiples of units? What is submultiples of units? We all are very familiar. That story is done. Okay. Now what today's plan is, I don't mind how long will it take, whether it's 11 o'clock or 11:15, actually I don't know. But my plan is to finish before 10:45 p.m. only. But based on today's workload, I might have to extend him. Right? Give me 1 second. Right. Okay. Today plan is, we are completing. Can someone reply in the chat box? Did you discuss compound unit section? Like under special names, we learned many. Right? We learned many. Can someone tell me, did I give a small table? Did I give a large table under compound names? For an example, area, meter squared, volume, meter cube. Can someone reply? I gave. Ne? I think I gave. In that case, I think I have done that part also. Yes. And until under that compound names, what is the last physical quantity that we learned? What is the last physical quantity that we learned? What is the last physical quantity that we learned under that compound names? Can someone reply quickly? Surface tension. Surface tension. Right, okay. I got it. Great. Surface tension. Great. Okay. Right. Shall we write few more? Write down today's date. Today's date and write down. Now every day make a habit. First important habit is, every day when you come for a class, when you start writing something in your note, please put your date. Definitely put your date. When you were in grade 5, 6, 7, you used to put the dates. but when you little by little, when you come to the O level, sometimes you missed and you lose the putting the dates. But hereafter A level classes, every day when you're writing something, put your data. It's very important, very important. Okay, we'll continue. I will give another set of physical quantities which come under compound names. So we don't need to take so much of time. We'll quickly write down. Write down continuation of compound units. Write down continuation of compound units. And again, break your book into three different columns. Column 1, column 2, column 3. We know column 1, the topic is as usual. Column 1 topic is physical quantity. Column 2, topic is SI unit name. Column 3 will be standard symbol. Right. 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 I found another set. That's why I'm giving this. Right. But you don't want to understand the real idea behind each physical quantity as I told last day. Right. This table writing will be finished definitely within 1 hour. Okay. Then again, you don't want to break your book into 3 columns and you don't want to complete tables. Okay. Today we are entering to a very nice lesson, dimensions. Dimensions. Okay. Within first 30 to 35 minutes, we'll plan the story and we'll finish it quickly. Right. Number 1, Young's modulus. Young's modulus. Young's modulus. Okay. Compound name, continuation. Young's modulus number 1. Young, Young's modulus. Modulus. Right. Then what is the SI unit that we use to measure Young's modulus? You don't know, I know. We are using Newton per square meter. Newton per square meter. Right. Newton per square meter. Square meter. The symbol is capital in Newton. Per square meter means in m minus 2. Next one, electric field strength. Next one, electric field strength. Electric field strength symbol volt per meter. Volt per meter. Right, symbol volt per meter. Volt per meter. Symbol capital V m minus 1. Capital V m minus 1. Number 3, electric flux density. Electric flux density. Symbol, the unit is coulombs per square meter. Coulombs per square meter. Symbol is capital C m minus 2. Next one, permittivity, 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 permittivity. The unit farads per meter, farads per meter, farads per meter, farads per meter. Symbol is capital F. Farad symbol is, we can remember, capital F. Farads. Capital F, M minus 1, farads per meter. Farads per meter. Next one, current density, current density, current density. So we will learn all these physical quantities in upcoming lessons. Current density, unit amperes per square meter, amperes per square meter, amperes per square meter, amperes per square meter, amperes per square meter. Next one, magnetic field strength, magnetic field strength, magnetic field strength, symbol amperes per meter, amperes per meter, amperes per meter, symbol AM minus 1, amperes per meter. Next one, permeability. It's not permittivity, permeability. Seventh one, permeability. 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 Henry per meter. 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 Symbol capital H, Henry per meter. Capital H, simple M minus 1, Henry per meter. Seventh one. Seventh one. Resistivity. Seventh, not resistance. Resistance measured in ohms. This is resistivity. Resistivity. Ohm meter. Ohm meter. Ohm meter, symbol ohm meter. Eighth one is electric conductivity. So last 6, okay, last 6 or 7, okay. Electric conductivity. So then we don't need to learn these stories. Finished, okay, perfectly finished. Electric conductivity, conductivity, symbol Siemens per meter, Siemens per meter. Siemens per meter. Siemens. SM minus 1. Capital is simple in minus 1. Ninth one, heat capacity. Heat capacity. Heat capacity. Symbol is joules per Celsius. If not joules per Kelvin. Joules per Kelvin. Joules per Kelvin. Symbol is capital J, joules. Joules per Kelvin, capital K minus 1 joules per Kelvin. 10th one, specific heat capacity. So we will learn these physical quantities widely in upcoming sections. Specific heat capacity. Specific heat capacity. Right? Writing. When will this finish? When will this finish, sir? When are we going to finish story? Specific heat capacity. Joules per Kelvin per kilogram. Joules per Kelvin per kilogram. Joules per Kelvin per kilogram. Per kilogram. Kilogram. The symbol. Joules per Kelvin per kilogram. But keep in mind here, Kelvin in the sense capital K, kilograms means simple K. Keep that in your mind. Last how many? Last five. Entropy. Last five. The last five. Okay, did I miss something? This is 7. This is 8. Okay, numbering 8. Okay. This numbering is 8. 8. This is 9. 10. Thank you. Thank you. Who's that girl? Thank you, Askia. 11. The last 5. 12. The last 5. The story finished. Entropy, thermal conductivity. Okay. Story going to finish. That's it. Entropy. In chemistry also, you will learn entropy widely. This is some kind of confusing section in chemistry. But in physics, we don't learn this in detail, right? We are not going to learn this in detail in physics, but in chemistry, you will learn the story. Entropy. Next one is thermal conductivity. Thermal conductivity. Then next one will be specific latent heat. Specific latent heat. Entropy, the unit. Joules per Kelvin. Right? Joules per Kelvin. Symbol capital J. Capital K minus 1. Capital J, capital K minus 1. Entropy. Next one, thermal conductivity. Watt per meter per Kelvin. 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 Capital W watt per meter means simple M minus 1. Per Kelvin means capital K minus 1. Watt per meter per Kelvin. Per meter per Kelvin. Specific latent heat, joules per kilogram. Joules per kilogram. Joules per kilogram. Joules per kilogram. Capital J simple kg minus 1. Capital K simple, sorry, capital J simple K simple G minus 1. I think you can't see here. You can't see here. Here I wrote this one, joules per kilogram. Joules per kilogram. The last two. Last two, I think. Last two. Luminance radiant intensity. Finished. Luminance radiant intensity. Luminance. Last one. Radiant intensity. Radiant intensity. Radiant intensity. The last two. But that's completely all right. You don't need to remind these stories. But there are some units that we learn in upcoming sections. Then with the practice, automatically you can remember these stories. So therefore, you don't need to remind these stories. Right? Candela per square meter. Candela per square meter. Candela per square meter. Simple C, simple D, M minus 2. The last one, finally. The last one will be watt per steradian. Watt per steradian. Watt per steradian. Okay. Watt per steradian. 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 Symbol capital W watt. Steradian, you can remember the symbol. Watt. Steradian. SR minus 1. SR minus 1. Okay, but we wrote simple, isn't it? SR minus 1. Story finished. Done. Once you finish writing, then raise your hands. Then complete compound units also. I think everything in our syllabus, I think I just gave the names. So therefore, compound units also perfectly done. Multiples, submultiples, completely discussed. Multiples also we can tell kind of derived only multiples, submultiples. Right? Okay, multiples, submultiples. Okay. Then we discussed multiples, submultiple stories. Finished. Then finished. Right. Once you finish writing, raise your hands. Once you finished writing, raise your hands. Once you finish, raise your hands. Quickly. Quickly. Right. So then what we do, we'll talk some, there are some important points where they can test in the exams in units. Right. There are some important points. So therefore, shall we put our topic, put your topic, take your notebook. So do we want to memorize these? As I told, basic 7 units learn by heart. Definitely, you must learn by heart basic 7 units. And supplementary 2 units learn by heart. Then keep in your mind, derived units means derived units comes from basic and supplementary. These units are derived from basic and supplementary. Supplementary we can categorize into 2 categories, special and compound, but keep in your mind, obviously I also can't remember some physical quantities as well as its units. Genuinely I also can't remember. So therefore you don't need to remember special and compound units you don't need to remember, but understand most of the physical quantities you will automatically remember with the time. When you are walking unit 1, unit 2, unit 3, 4, 5, 6, 7 until 11, with the practice now these are very new for you, but with the practice automatically remember all these 11 units. Therefore you don't want to remember these physical quantities in special and compound stories. Okay, right? Okay, story finished. Story finished. Now put your main topic. The last theory sections in units, then we are entering to dimensions. Put your main topic. Main topic. Facts to be write down. Facts to be considered when using SI units. Facts to be considered when using SI units. So use different color pens. No need to use red color pen, but use different color pens. Number one, write down. If you are using, let's say, black color, so if you're using blue color as your usual pen, then you use your black color pen. If you're using black color, then use your blue color pen. It's up to you. Number one, write down. Only the relevant type of units, only the relevant types, only the relevant type of units with its multiples or submultiples, with its multiples or submultiples should be used to measure, should be used to measure should be used to measure a particular physical quantity, a particular physical quantity. What that point says, a particular physical quantity. When you missed, right? Sometimes when I quickly say, sometimes you can't write, you can't catch it up. In that case, what you do in that AS Academy chat, put a reply, sir. What were you saying after this word? What did you tell? You just put like that because I am looking your chat. If I repeat the heading again, repeat the heading again. Facts to be considered when using SI units. When using SI units, right? Facts to be considered when using SI units. That is the heading. Then we wrote the first point. Now, what this first point says, can you give an idea? Very simple. Now, as an example, I take mass as my physical quantity. Right? Point number one. I am taking, as an example, I am taking mass. Mass. Now with this knowledge, because you are studying with me for last 2 weeks, now if I ask you, you definitely you can tell what is the SI unit to measure mass. We all tell that definitely kilograms. Definitely kilograms. Okay, definitely kilograms. We are using kilograms because we know the unit, the relevant unit that we are using to measure mass is kilograms. We have that understanding, right? But suppose just think, if you don't have this understanding, sometimes some of you can use meters to measure the mass. Yeah, we have the practice. We know that meters should be used to measure length. But if you don't have the right understanding from your childhood, one can tell, sir, why can't we use meters to measure mass? Why can't we use seconds to measure mass? It's a problem, right? So that's why first point says that. That's why first point says that when you are measuring a relevant, when you are measuring a physical quantity, you want to use the relevant unit system. You want to use the relevant unit. When you're measuring mass, you can use kilograms. Right? Another example, let's say you are measuring the time. The next example is, let's say example 2, you are measuring time. So we know that the relevant unit to measure time is, we all know it's seconds. Seconds. So you can use multiples of multiples. Right, you can use multiples. That means kilosecond, megasecond, right? You can use kilosecond, megaseconds, gigaseconds to measure the time. If not, you can use sub-multiples, millisecond, microsecond. You can use sub-multiples, micro, milli, nanoseconds to measure the time. These are sub-multiples. So these are sub-multiples. Sub-multiples. If not, you can use multiples. For an example, if you're using multiples, kilosecond, but we don't use but you might have observed we are using millisecond, microsecond, but we are not using kiloseconds, megaseconds. If you want to measure larger time, we are using minutes, hours. If not, we're using days, years. So in the practice, it's very rare to use kiloseconds, megaseconds, gigasecond, but can tell kiloseconds, capital M, mega, capital G, giga. So these are multiples. Last day I taught you. These are multiples. Right, I hope you understood. To measure the physical quantity, you want to use the relevant unit. To measure the time, you want to use seconds. You can't use meters to measure time. You can, along with the SI rate, you can use multiples or sub-multiples. Right? So as example, write down these. Put correct, put wrong, right? Multiples. First point, multiples. These multiples, sub-multiples. Done. So always make a habit. Don't you look at others. Once you finish writing, make a habit. Yes, you raise your hands. Once you finish writing, make a habit, raise your hands. Right? If I repeat the first point again, okay, while you're writing, I repeat the first point again. Only the relevant type of units with its multiples or sub-multiples, comma, only the relevant type of units with its multiples or sub-multiples, comma, should be used to measure a particular physical quantity. If you finish, raise your hands. A particular physical quantity. Right? Then write these two examples. If you finished writing, raise your hands. Okay, keep in your mind every theory point in detail with proper explanations I am doing. Right? If you have watched my YouTube recordings right now, you understand, right? You can get an idea. Sometimes when you compare with your O-level science classes also, when you compare it, when you look at my discussions, my explanations in my YouTube videos, you understand how deep I am going in every point. Even you didn't learn those theory parts, when you just watching the recording, sometimes you see that, you think, you feel that you understand easily. Number 2, write down. Second point, write down. Same standard symbol should be used same standard symbol should be used as the symbol of unit. Symbol of unit. Symbol of unit. In both singular and plural instances. 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 Now, some of you have an idea like this. Sir, let's take an example mass. So when the mass is 1 kilogram, it is singular, right? When the mass is more than 1 kilogram, 2 kilogram, 5 kilogram, 10 kilogram, it's plural, right? So if it is 1 kilogram, if it is 1 kilogram, some of you are arguing. I know you don't, but some of you still think like that. When you are measuring 1 kilogram mass, they tell, yes, I want to put, if it since it's 1 kilogram, since 1 means singular, I want to put the unit as simple K, simple G. But if I'm measuring a plural value, large than 1, 2 kilograms, 5 kilograms, 12 kilograms, since these are plural, I want to use kilograms. 12 kilograms. Is this correct? Wrong, right? So when you go to the English, I don't know English that much, but mother singular. No need to tell that example is very bad example. So we'll take book. Book is a singular. Books plural. When you tell one, if there is only one book in your table, you tell one book. But if there are more than one book, you tell two book, three book. We tell two books, three books. If I'm correct, grammatically, if I'm correct, I think that's the idea. Please don't argue with me because I'm not good at English, right? But in here, we know understand we can't use the story. We can't use kilograms. No, we can't use. Wrong. Even the value is 1, no more than 1, 5 or 12 or 10,000 no 1 lakh. Unit is always same. Kilogram is kilogram. Right, 1 kilogram, 5 kilogram, then 12 kilograms. Sorry, 12 kilogram. 12 kilogram. I hope you understood. This is the second point. Right? So then example right on this one quickly. Once you finish, raise your hands. If I repeat the second point again, same standard symbol should be used as the symbol of unit, in both singular and plural instances. In both singular and plural instances. In both singular and plural instances. Right? Done? Finished writing? Point number 3. Write down point number 3. Simple English letters should be used. Simple English letters should be used. Simple English letters should be used. For all other symbols, of units except the units named after scientists. Except the units named after scientists. Full stop. Okay, now you continue to the same line. First letter of the symbol. First letter of the symbol. First letter of the symbols of the units of the units named after scientists. Named after scientists, comma, should be written in English capital letters. Should be written in English capital letters. Should be written in English capital letters. Highlight. Should be written in English capital letters. Highlight. Should be written in English capital letters. Highlight. Please highlight. First letter scientist, capital letters. Highlight these three words. First letter scientists, capital letters. Look here, this story. I told you that when I was explaining derived units with special names. I told you uh, we right, next point. Third point is right, when I was explaining derived units, special names part. So we know that all the units are defined with the names of scientists. If it is if the unit is derived from names of scientists, I told you first letter should be capital. For an example is Newton, right? So Newton means capital N. For an example, Newton means capital N. If not Pascal, right? When you consider Newton, it has only one letter N. If you are measuring the pressure, the SI unit to measure pressure is Pascal, capital P, simple E. Always first letter must be capital, right? If I do another example, amperes. Ampere means name of a scientist to measure the current, capital E, right? First letter capital. But when you consider there are some other units, those are not the scientist names. For an example, meter starts from simple. Seconds, simple less. Kilogram, simple K, simple G. Kilogram, simple K, simple G. So therefore, the units which are not starting from scientist names, first letter is simple. The units derived from scientist names, first letter must be capital, right? So just example, you write these two columns. Just mention first letter capital, first letter capital. That story. That story. It's not that much big problem. It's not that much big problem, right? Quickly. Please, once you finish, raise your hands. So we have another 7 points, and then theory wise, unit section perfectly, properly finished. I took around 2.5 weeks. We started the classes 2 weeks before. I haven't done a perfect complete class. Also, I did 2 hour, 2.5 hour classes, but we took 3 weeks. But upcoming days we are not doing that. Okay. Next point. Point number four. Point number four. Write down. Point number four. Write down. The symbols of units. The symbols of units should always be written. Should always be written after the numerical value. After the numerical value. Full stop. And also there should be a and also there should be a little space between little space between value and the symbol. Value and the symbol. Some of you, what you guys do, some of you, let's say when you are measuring a length, for an example, the fourth point says that some of you, when you are measuring a length, we know the SI unit is meters. So when you are measuring that length, you observe that length of that wire row, length of that rod is, you are getting it's 5 meter. But what you are doing, you are writing like this, 5 meter, you are writing meter 5, m. After writing the symbol only, you are writing the magnitude, meter 5. Is this wrong? Always keep in your mind, first you should write the value. After the value only, you should write the symbol. So therefore, this is wrong. This is 5, yeah, not seconds, 5. So the right way is, first of all, you should write the magnitude first, value first, 5. Then the unit, 5 meters. But again, even some of you write like this, some of you do another mistake. Some of you do another mistake. What they do, they just write 5 meter like this, 5. They write 5 meter like this, see. They don't keep any space between value 5 and the symbol simple lim. They try to write simple lim very close to 5. Keep in your mind, that is also wrong. When you write something like this in your exam, it's wrong. They don't give marks. Why? Here no gap. Here no gap. There should be a gap. No gap. So therefore, keep in your mind hereafter, when you're writing a magnitude symbol, magnitude should be first, symbol should be second, and also there should be a small gap between magnitude and the symbol. That is the point I said, right? That is also done. Next point, point number 5, write down. Point number 5, write down. Point number 5, write down. These are very basic points, but it's my responsibility to explain all the points. Because even you are bright, sometimes you can do mistakes in these points, right? Fifth one, write down. Hands up. How many of you say, am I too speed? Hands up. When I'm saying, am I too speed? Hands up. I'm okay. My speed is okay. Hands up. My speed is okay. Okay, right? Great. And write down the next point, point number 5. Then we have 10 points. Fifth one, write down. Symbols of the prefixes. Symbols of the prefixes used to indicate a million or above. A million, MILLION, a million or above. A million or above. A million or above. Should be written in English. Should be written in English. should be written in English. English capital letters, full stop. English capital letters, full stop. This is kind of very good point, okay? Continue to the same point, continue. Symbols indicating values. Symbols indicating values. Below that. Below that. Below that. Should be written in English simple letters. Should be written in English simple letters. Okay. What it says, this point. Now this point is important. So you also try to remember this point. Okay, this point. Point number 5. Now you can remember we learned about prefixes and prefixes, multiples and submultiples, right? Multiples, submultiples. They are prefixes, prefixes, multiples and submultiples. So give some examples of multiples, submultiples. Multiples, you can remember. I taught you. You can remember. Multiples means we all can remember. Look here. Multiples. We can remember kilo, then centi, simple C, deci, simple D, right? Kilo, suddenly, ni, deci, centi, kilo, simple letters, you are prefix. Then mega, then giga, tera. You can refer your table. Okay, lastly table, just to take your table also. Mega, giga, tera, capital letters. So these are, we know, multiples. These are multiples. These are, all of these are prefixes, but these are multiples. These are multiples. Multiples. Keep in your mind. I told the story. And also, submultiples, give some examples. Submultiples. Submultiples, we can remember multiples. Okay, submultiples. Sorry, here I did a small mistake. Here, deci, kilo, then deci. I made a small mistake. Kilo, deci, I made a small mistake. Then I told you, yes, kilo, hecto and deca. Hectodeca, simple is simple D. Okay, I made a small mistake. Here, multiples, hecta, deca, D simple is a multiples. Submultiples only starts from deci. Submultiples starts from deci. You know that deci, simple D, deci. Then centi, milli, micro, nano, pico, atto, whatever. So these are, we all know that submultiples. So these are, we all know submultiples. Right? These are submultiples. There's a point. That's why I'm telling. Submultiples, keep in your mind. Submultiples. These are multiples. These are multiples. Multiples. Commonly, multiples and submultiples are called as what? Commonly, we are calling them as prefixes. Commonly, we are calling them as prefixes. Okay? Prefixes only. We are the common name for these two prefixes. Now, my point is, if the prefix value, now I taught you every prefix, every multiple, every submultiple has a unique value. If it is kilo, you can remember its value is 1000, 10 to the power 3.
If it is mega, I told you 10 to the power 6. If it is milli, its value is 10 to the power minus 3. Every prefix, so every prefix has a certain value. They are telling, if the value of the prefix, look here, they are telling if the value of the prefix greater than or equal to million. Now, million means how much? 1 million rupee. 10 rupees, you can write like this 10 rupees. Then 100,000 rupee. 10,000 means like this, four zeros, 10,000 four zeros. 1 lakh, 1 lakh means 100,000. 100,000 is 1 lakh. 1 million, for 1 million, how many lakhs? 10 lakhs. So then another zero. This shows about how much? 1 million. This is 1 million. Am I correct? 1 million, how many zero? There are 6 zeros. 1 million means, keep in your mind, 1 million means 10 to the power how much? 10 to the power 6. 1, 2, 3, 4, 5, 6. When you convert to scientific notation, 10 to the power 6. They are telling if the value of the prefix is equal or greater than 1 million. Greater than 1 million means 10 to the power 6. Then they are telling the symbol of the prefix must be capital. Then the prefix symbol is capital letter. That's why you have seen, look here, kilo means how much? 10 to the power 3. You all can remember, mega means how much? Mega means, what is the value? 10 to the power 6. Mega value is 10 to the power 6. 10 to the power 6 means 1 million. Then we should write the mega, the prefix as capital letter. Why? That prefix value is equal to 1 million. Capital M is about 6. 10 to the power 6 means 1 million. If it is 1 million, prefix symbol we should write in capital letter. Then beyond that, giga means 10 to the power 9. That is greater than 1 million. Then its symbol is capital G. Tera means about 12. Its symbol is capital T. Right? So therefore, keep in your mind these three. Right? These three, yeah? Right? These three, nicely write on these three. These three, capital. Capital. Hands up, the story is clear, hands up. This story is clear, hands up, online. Last 5 minutes, last 5 points, then we are taking a small break. This story clear, hands up. Right, if it is clear, quickly write down these things. These things. Don't worry. Even your theory book, whatever I write in your note, whatever I write in the whiteboard, if you feel it's important, even it's important for you, not important, it's okay. Whatever I write in the whiteboard, just keep on writing your notes, right? Because when you go to a university, you understand. Now, when you are O-level classes, now L also, we are giving very nice note. So you have a very nice note because you don't need to worry. Your teacher gives a nice note. Your teacher draws the diagram and everything. But once you get into the medical faculty, once you get into the engineering faculty, you know that the time duration is 4 years, 5 years. If you are going for medicine, 5 years, sometimes 6 years also. Throughout your 6 years, keep in your mind, your lecturers, your professors, they don't give any note. But obviously, you can sense what type of study that you have to do in your university. Definitely complex than A levels. O level period, grade 5 easy, A level complex. A level period, obviously, you know that university study is very complex. But A level classes, even though the theories, everything is complex, there is your teacher is, if you go for a proper class, your teacher guides you A to Z. Your teacher gives the right note. Your teacher do questions and your teacher explains how to solve a question. Your teacher do paper class. Your teacher is doing past paper discussion. Every time your teacher is motivating you. Right, personally, when you ask a doubt, your teacher sorts your doubt as a WhatsApp message. You personally, your teacher helps you to sort your issues. But when you go to the university, keep in your mind, you can't ask doubts from your professors.
You can't go there and you can ask, I have a problem, I didn't understand. You didn't even teach properly. So therefore, please explain this. When you do like that, what will happen? Let's say you go to the lecture hall. So you went to the lecture. Your professor obviously he doesn't teach actually. In universities, any professor don't teach. So what you do, you just go and ask. You didn't even explain this properly. I have a doubt. Please sort out this issue. So he don't explain anything, but somehow let's say using internet to some other resources in your university books and you refer it and you study it. But what will happen? You study it very well and you do the paper also very well. But in the exam semester result coming day, when you look at your result is W. You did very well, but sometimes your professors have the right authority to put W of fail even you did very well. So that's a right for professors. They can decide. Even you marks is 100 out of 100, your professors, lecturers have the right to put 0 marks also. So therefore, when you go to the university, life is completely different. Right now, here every point is detailed, taught very clearly. But keep in your mind, in your university, they don't teach. Sometimes they just put the heading and they just tell some 2 3 words that we can't even hear it also, and they just leave. So what they expect in university is the professor's ultimate goal is you should learn by yourself on. Now here I am the teacher. Now here how do you learn the stories? How you are learning? I am a teacher. You are the student. You get my knowledge actually. I am giving the knowledge to you. Right? I am explaining. I am doing question. Then you are learning by grabbing what I tell. You are learning, right? But in university, what is the goal? You are the teacher and you're the student. By using the resources like books, using the resources like internet, so you want to create your own note. You want to create your own note. You want to create your own study plan, study method. You can't ask help from others. That's the way. So that's okay. I just told. Therefore, in my university period also, what I have done, whatever my lecturer professor writes in the board, sometimes he just write like this. Sometimes what he do, he write some just lines and he just go. But sometimes what I do, I write those lines also because I think if he write a small line, there might be reason behind that. Therefore, I just note that right also. And he explains so fastly. He explains so fastly, right? So then my eyes, not only my eyes, when you go to the university, you understand that all our people's students' eyes only on the whiteboard, only on the board. So we are not looking at the book. So we are looking at the whiteboard. We are looking at the professor's mouth. Our focus is on the mouth of the professor and on the whiteboard. Parallelly, we are looking the mouth and we understand the way the mouth shakes and we try to understand what he is telling. Now you can hear my voice. Now you can hear my voice nicely. Suleiman, he's telling Suleiman. So you are not looking my mouth, right? You are not understanding what I'm saying using my mouth vibration. Sometimes in our lecture halls, what we do, so parallelly looking the whiteboard, what his hand writing and how his mouth vibrates. If I talk like this, right? You can understand what's your name. Likewise, parallelly we are doing that. Our hand is continuously writing. Handwriting becomes very ugly. That's okay. Any university students' handwriting is ugly, but that's how we learn, we practice, we write the notes in uni. So therefore, definitely you will go to the university. Definitely, if you study very well, whatever. Even I don't know how the things going in private universities. I don't know, but if you are going for a government university, engineering or medical faculty, is the normal practice. So therefore, somehow what change yourself. Somehow what adopt to your upcoming future targets, right? So first of all, now the biggest challenge that you have right now is sometimes when I tell you to write down, when I keep on telling, sometimes you miss it. Sometimes you think that I am telling so fast, but somehow it might be true. Sometimes you quickly adopt to my speed. So don't expect me to come to your slow speed. I can't come. Then we both are in the same, always in the down level, right? So that's the thing.
Okay, right, okay, right, okay, right. Then okay, 0.5 also done. Last 5 points, then we'll take a break. Then we can start dimensions. It's a calculation part. It's bit interesting than these units. Right. Last point number, I think 6. Write down. Point number 6, write down. When writing multiple units, comma, when writing multiple units, comma, a dot shouldn't be kept. A dot shouldn't be kept in between the prefix and the unit. In between the prefix and the unit. In between the prefix and the unit. Look here. Same story. Look here. Example. What some of you do, point number 6. Point number 6. When you are using multiples, submultiples, prefixes, when you're using prefixes, what some of you do, for an example, let's say you are measuring a length, very small length, therefore you are using a prefix milli. Phi, since the length is very small, we are using a prefix submultiple in front of SI unit meter, 5 millimeter. Millimeter. So, right, milli means the prefix, if not submultiple, meters. What you guys doing between the prefix and the symbol? Some of you put a dot in between. That's wrong. Sometimes in O levels, when you are doing maths questions, some of you have done 5 into 2 means you guys write like this. 5 into 2 means you guys write 5.2. 5 dot means 5 into 2. Some of you, what you do the same thing for the story also. Between the prefix and the unit, between the prefix and the unit. So you guys put a dot. It's wrong. It's wrong. Huh? Prefix is the unit. Then you have put a dot. That is wrong. There should not be any dot between the prefix and the symbol. So if you are writing 5 millimeter, it should be 5 millimeter. Look here, millimeter. That story. Quickly write down. I think you guys understood. It's not that much difficult. You can understand. Point number 6. Point number 7. Point number 7, write down. Point number 7, write down. A prefix should be used along a prefix should be used along with a unit symbol, UNIT, units. A prefix should be used along with a unit symbol, comma, given that the numerical value given that the numerical value given that the numerical value exits exits in a range between, in a range between, in a range between 0.1 and 1000, 0.1 and 1000, 0.1 and 1000 full stop. Now, for an example, look here, 0.1 and 1000 full stop. Look here. Look this. Look here. Now, point number 7. I'll ask you a question. Now, look here, everyone. Look at here. Look at here. Careful listen. Keep your focus. Now we know what is joules. Joules means we all know a symbol to measure. SI unit to measure the energy. Okay. Now, what is the best way of writing? Now we know by using a prefix, I can write down. Look here. Look here. Look here. Look here. Now, look here. 200,000 joules. I can write the same story. I can write as 200,000 kilojoules. Okay. So 200,000 joules means if you use a prefix, the kilo means we all know kilo means about 3. Kilo means you all know. Look here. Now these two are same. I'm telling these two are same. Why? Because kilo means you all know. I taught you last week. Kilo means 10 to the power 3 into 200. That means again we are ending with how much? 200. 10 to the power 3 means 3 zeros. 1, 2, 3. So you understand this value and 200 kilojoule means both are same value, same story they are telling. This story is same. What is much preferable? Writing this value in joules is better or writing this value in a kilojoule is better? Hands up, if you say, hands up if you say, writing this option is better answer. This is better answer. This is writing 200 kilojoules. This is better. Option 2 is better answer. Option 2 is better answer. Option 2 is better. But rather than writing like this, writing this as 200 kilojoule is better. Right? There is story. Example, write down. Example. Example, write down. Example. Sir, can't see the bottom of the board. Okay, I will write down. Look, I wrote here. Sorry. Look here. I wrote here. Now 200 kilojoules means keep in your mind. 200. You all know kilo means how much? Kilo means we all know 10 to the power 3. We all know kilo means we all know 10 to the power 3 joules. Right. So therefore now these two are same only. But when you write like this, it's not that much suitable. When the value is so much larger. If you use a prefix called kilo, you can reduce the value and it will be very easy also. So therefore, rather than writing this way is much better. Let's write an example, Example, write down. Writing 200 kilowatts is more appropriate than writing 200 kilowatt is more appropriate than 200,000 watts. Last 10 minutes. 200,000 watts. Last 10 minutes. Then we can take a break also. We start the class around 8:05. Time is almost for half an hour. We should take definitely a break. Last 3 points. Then we can finish story. Point number 8, right on. Point number 8. 8. Prefix are not written separated from the units. Write down. Prefix are not written separated from the units. Prefix are not written separated from the units. Point number 8. Look here. Example is now Tell me, put a prefix and tell me a symbol. Meters means millimeters. Second means millisecond, microsecond. For an example, microseconds. I'm using a prefix micro, right? Micro seconds. Now, how someone writes that microseconds? They write the prefix micro, keep a kind of blank and write the seconds. This is wrong. When you're writing the prefix with the symbol, you should not keep any blank. You should not keep any blanks. If you are writing this prefix with the symbol, there should not be any gap between prefix and the symbol. Microseconds. Now here I told you, when you're writing the value with the symbol, there should be a gap. But when you're writing the prefix with the symbol, there should not be any gap. Example explains the story. With the practice also you understand, right? I think you can understand, right? No need to explain more deeper, small things. Right, point 8 also done. Last 2 points. Last point, write down. Last 2 points. Point number 9. Point number 9, write down. Point number 9, write down. Last 2 points, okay? Write down. When writing compound units symbols, when writing compound unit symbols, comma, a dot can be used to indicate, a dot can be used to indicate, a dot can be used to indicate a dot can be used to indicate a dot can be used to indicate a product of two units. When you're writing, try to understand what you're writing. Don't read until I explain something. Before I explain, you imagine, right? Before I explain, you imagine the story. Then you can remember very well. Okay. When writing the component symbols, comma, a dot can be used to indicate a product of two units, full stop. A product of two units, full stop. Continue. But writing units without the dot is not wrong. But writing units without the dot is not wrong. But writing the units without the dot is not wrong, comma. Only in case where only in case where it seems to be no way off. It seems to be no way off. It seems to be no way off. No way off. Clashing with another unit. Full stop. Clashing with another unit. Clashing with another unit. Full stop. But two units should be written. But two units should be written slightly separated. Don't worry, I will explain. Two units should be written slightly separated. Two units should be written slightly separated. Now it's not a big story. Look here. Point number 9 is they are telling, let's say when you're writing compound, now under derived units, we talked about compound units and special name. When, for an example, tell me a compound unit. For an example, we can tell that Newton meter. Compound unit, we know that an example, compound unit, Newton meter example. Newton meter. If not, another component is kg, kilograms. M is minus 1. Right? There are many units involved in components. Kg, M is kg, M is. These two, what this is 1, 1, 1. There are 2 units involved in this component. So what some people do to separate, to show that kg is a different unit, meter means a different unit, second means a different unit. What they do, what some students do, they just put a dot between the separate units. For an example, between Newton and meter, because Newton is a different unit, meter means a different unit, because there is a unit called Newton meter. So to separate Newton meter, they are putting a small dot in between. So for an example, kg m is minus 1, they put a dot kg, then they write simple m, kgm, again they put a dot and write the seconds to show that kg, simple m and simple s are separate units. It's not wrong. It's okay. It's correct. It's not wrong. And if you write Newton meter as Newton dot simple m, it's not wrong. It's correct. It's not wrong. It's correct. No issue. It's okay. It's correct. But you can put some dots in between and you can write it obviously to show kg, ms are separate units. But in practice, we are not using this in practice. You can use, even you write the symbol of this symbol putting dots, no issue, they give marks, no issue with that. But as a practice, we rarely we put dots in between. Normally, without any gap, we write this like this. Newton meter means Newton meter, very small, very slightly small gap, because some people write Newton meter as like this. Some people write down Newton meter as like this, Newton meter. Then can't understand me. So therefore, there should not be any gap between these two, but a slight, small, very small gap is there. Kg m is minus 1. This is also right. This is also right. No issue. But keep in your mind, you can't put a dot in a prefix. When you're using a prefix in front of a unit, you can't put a dot in between. Where that point is where? Here. If you are using a prefix, millimeter, kilometer, you can't put a dot in between. You should not put a dot in between to separate the prefix and the unit. It's wrong. When you're using a prefix in front of a unit, definitely there should not be any unit. Your prefix must be very closer to the unit. The story. The last point, then we can take a nice break. We can drink some water, we can eat something, and we can start a new lesson. I told you, your unit 1 section contains three sections. Look here. Unit 1 contains 3 sections. First section is almost, we took around 3 weeks and completed. Going to complete units. Very fundamental, very basic stories are there. Right. Second section is dimensions. That is somewhat complex for your level. Dimension, second one. When talking about units and dimensions, you understand these are theory based. Unit section is much biased to the theory, more theory. See, we have plotlet, we have drawn set of tables and writing, and nothing there to do questions. Yes, last week we converted some multiples and submultiples to SI units, but those are not calculations, right? So unit section is much biased to theory. When you go to the dimension section is bit biased to beta, not entirely, bit biased to calculation. There is one last part, that is the practical part. In your exams, definitely out of 4 structure essay questions, 1 structure essay question will be asked from unit 1 practicals, measuring instruments. Right? Under measuring instruments, we are learning 4 different measuring instruments. I plan to do this on May 1st as a separate online class, extra class. Measuring instruments. If you are coming physically, I will bring the
instruments, vernier caliper, micrometer gauge, and we are doing these practicals physically in our physical class. But since if you are joining online, so you have to refer through online, you have to go through online. Okay, that's the way. So this is the most practical theory, practical part. This is theory based, dimensions calculation based, practical based. Okay, the last point we'll write down the last point write down, last story, last story, last point, point number 10. Sometimes you are aware about all these points. Write down. When writing compound unit symbols, when writing compound unit symbols, with a division, comma, use a slash. Use a slash inside the bracket. Look here. Use a slash inside the bracket. Mark by the slash symbol. Use a slash inside the bracket. Actually, write the slash symbol, comma. Sorry, use the slash inside the bracket slash symbol. Close the bracket, or a horizontal line, or a horizontal line inside the bracket. Write like this. Close the bracket, comma. Otherwise, express the denominator. Express the denominator. Otherwise, express the denominator as a negative power. As a negative power. Otherwise, express the denominator as a negative power. As a negative power. Okay, the last theory part in unit section, then we can completely finish unit section. Now, this story you all are aware. For an example, look here, for an example, let's say density. Density means we all can remember. Density means we all know the equation. If you can remember, density means we all know mass over volume. Mass over volume. Now, my question is, I'm going to ask, what is the units of density? Then we all know mass is measured. Units of mass, we know kilograms over the units of volume. You all know that meter cube. Right? If I ask you to tell, if I ask you to write the units of density, so we don't keep units like this. One will write the units as kg. It's a division meter cube. One student can write like this. What another student do, he doesn't like to keep a division. What he's doing, if you bring, now what is the power of meter? Power of meter is 3. When you bring this meter cube to the numerator, all level knowledge, all level you learn that 1 over x to the power 6. You can remember, when you consider one division x to the power 6, what would happen when you bring x to the power 6 to the numerator? Now, x to the power 6 is at the denominator. If you are moving it to the numerator, we all know that this power becomes a negative value. Am I correct? Now, when this x to the power 6 is at the denominator, power of 6 is a positive value. But if you are bringing this x to the power 6 term to the numerator, we all know that it will become what? 1 into x to the power minus 6. Oil story. Same thing happens in here also. If you bring m to the power 3 to the numerator, it will become m to the power minus 3. Other possible way of mentioning the density units as kg m minus 3. Most of us, we are using this one very frequently, but some of you still using this one. But there is one way also, kg
Division means you can put a small line like this, and writing this is not that much possible. So we better we avoid writing like this. These two. Write these two as example. Put correct, story finished. Okay, done. Finished. If you have doubts, any concern, any issues that you faced, everything, feel free to talk. There are some issue with the tudes. Don't worry. I already sent the tudes. You will get them. Don't worry. Nothing to worry. Nothing to worry. You will get them. Okay. Genuinely hands up. The first section in your syllabus, detailedly from A to Z, completely discussed. Every point we learned. If you very clear, it's a theory part. It's a theory story. Nothing there to explain in deep. Nothing there. Actually, I can't explain anything in deep. But I tried maximum to make you understand everything. Genuinely hands up. This section is crystal clear answer. It's crystal clear for me. Every point, without any doubt, I got everything very clearly hands up. Crystal clear. Again, I remind you, if you have doubts, don't load your doubts day by day. It's completely all right. You are awkward, or you are annoyed, or you feel a bit guilty, or you feel a bit shy to ask. That's completely all right. Ask, because I'm your teacher. Since you selected me as your tuition teacher, or anyhow, I'm your teacher, because I know everything. You don't know everything. That's the story behind you and me. So to know everything, you can ask. You want to reveal you want to open you want to ask doubts. The silly doubt is also really appreciated, really welcome. Even your doubt is very silly, put in my WhatsApp message, privately message. If you don't like to share in the group, if you think that everyone will laugh for your stupid doubts, completely all right. Only share with me. Only share with me, but don't load your doubts. Day by day, when you load your doubts, what will happen? It will become a very huge doubt. Then one day, what will happen? Your physics lesson will be a big doubt for you. If you load the doubts day by day, right? Then the biggest doubt will be, so what is physics? I don't understand. That will happen in near future. Don't load your doubts. It's time to take the break continuously now. See, today 8:05. I know it's very hard. I'm really sorry. Time is 9:40. Normally, I give the break within the first 1.5 an hour before, but today we have to take the break a little bit later. How to do? This is the way. In upcoming days, this is what will happen. Sometimes you feel very difficult to focus, but don't justify like that. Right, sir, I can't keep my focus continuously. I can't. So I'm leaving. I'm sorry. So I will watch the recording. Don't be that. Try to stay there. Try to resist that reluctance that you have. Try to resist it. Put to give up kind of fight with that resistance, and somehow improve, adopt yourself. This online classes, online AL classes. If not, what will you do? I will tell you the story. If in my A level time period, if there were online classes, there weren't any online classes. If there were online classes, I would have joined to online classes because of the benefits. As I already told in the very first introduction session, I would have joined. But still, many don't understand the benefit of online classes. How you are going to justify in your near future? Sir, I can't focus by joining through online. Therefore, I thought of to get the interaction. I thought of joining a physical class. No issue. No issue. Right? If you go to physical class, it's really interactive than online. But in my class, I'm trying my maximum to keep the interaction. But comparing it online, when you join a physical class, just the interaction is very high. But you have to spend a lot. The time, the value, the money, the tiredness, everything you want to spend for that. But what will happen if you go for a wrong physical class? What would happen? Again, later, after 1.5 year later on, you will come back to again same online class. I went to this class, but there were many problems. Again, I joined your class because I like your teaching pattern. So therefore, don't do that. Be very careful. The best option is every day when we grow in our life. Think when you are a kid, then when you are as a O-level student, then when you just start A levels, you can understand the weight, right? So everyone now, when you just started doing A levels, but you can feel kind of a weight. When you are a kid,
the life was not that much complex. But when you were spending your all levels, yes, it was kind of complex. Every day in our life is getting more and more complex. The best thing is to adapt to our life, not to resist the life and always staying in the same level, because our life is going to be more and more uncomfortable. All student, as a AL student, it's very uncomfortable. When you go to the university, it's very, very uncomfortable. When you go for a profession job, it's very uncomfortable. If you take responsibilities, like if you become parents, and if you take responsibilities of your kids, and if you are doing your studies, if you are trying to achieve your future career, then your life is going to be very uncomfortable, very uncomfortable. In order to success your life, what you should do, you should somehow practice that uncomfortability, and you want to make that uncomfortability into comfortability. Very difficult. The best example is wake up early in the morning and doing prayers, very uncomfortable, right? So if you might doing that early in the morning when you wake up and doing prayers, very difficult. In the beginning, very difficult, can't wake up. But somehow by putting your mind, putting your heart, and when you bring in together, and when you manage to wake up 1 2 days thereafter, if you don't wake up, you feel very sad. You never, you sleep, you definitely will wake up. Very similar stories in this story also, like keep in your mind, right? Okay, we'll take a small break. How long you guys want? How long you guys want? How long you guys want? All right. So what do one student is saying, sir? Can you separately write the 3, 5, 7, 8, 9 points example? I could not write it because of network issues. Please, someone, I don't know, it's Tarika ho, it's Dwaraha ho, Tarushigan no, anyone, be the first one, and can you please put your note, what you wrote? If you have a good handwriting, please can you put it as in the group? Take a small photo and put in the group, right? Some of you could not write them. How long you guys want? Reply everyone the break. We'll take a small break and come. How long you want? Reply everyone. How long you want? How long you want? Reply everyone. Quickly, quickly, no time. How long you want? Reply everyone. 50-minute break. Or we'll go with the 15-minute break. We'll take a 15-minute break. Time is 9:46. Come at 9:45 minutes, 10 o'clock. Come at 10 to. Come at 10 to. Take your break and wash your face, eat something and come. Yes, take your break and come. Yes. Yes. Put your main topic with a very fresh feeling. Time is almost 10:05. We will do the class until maximum 10:45, but I will finish before 10:45 as well. Right, depends on the scenario. Sometimes I will stop before 10:45. Just keep in your mind, maximum you are going to stay with me for another 40 minutes. Right. Put your main topic. This part is bit complex than the unit section. Already, before I start the lesson, I tell you the story. Right. Put the topic. Unit 1, dimensions. Dimensions or dimensions. I don't know what is the right spelling. I don't know. Dimensions. Okay. Keep your focus until class finishes. This is very important part. Don't you miss this part. Every MCQ, there will be one MCQ coming from dimensions, one solid marks. One solid marks in your exam. Don't you think it's just 1 marks, therefore I don't want to bother? No, every 1 marks matters. Right. Okay. Dimensions. Right. Okay. Okay. So first of all, I will tell you some stories. So then we'll go in deep. Now, as I told, you can remember we learned 7 basic units. Right. Okay. And I talked about derived units. That you know what is derived units. Derived units are derived from basic units. We all know derived units are derived from basic units. We know that story. Right? Okay. Dimensions. Next section. Right. Right. So we learned 7 basic units. And I said that derived units are derived from these 7 basic units plus that supplementary units. Hereafter, just think derived units are derived from basic units. Keep that in your mind. Okay, right. Sometimes, so you want to understand when you take derived units, you need to understand how this. So you are telling. We understood derived units are derived from basic units. We are very clear with that point. Sometimes what we do, we want to understand how these basic units are involved in a derived unit. Okay, we need to understand, sir, how these basic units are involved in a derived unit. For an example, let's consider, give me an example for a derived unit. Example is area. Example is area. So we all know that when you consider area, we can remember the equation. Area means length into width. Length into width. That means simply it's a kind of length into length. Okay. Area means length into width. So we can identify length is a basic unit. Width is also a kind of length. Therefore, width is also a basic unit. Right. The basic unit is length. The width is also a basic unit length. So very clearly we can understand this derived unit area is derived from basic unit called length into length. When you multiply basic unit called length into the length, then only area derived unit is formed. Am I correct? That's very clear. We can very transparently we can see that idea. If you consider volume as an example, volume is a derived unit. Then the equation is length into width into time.
We know length is also length, width, and height. Length, width, and height, all three are lengths. Length is a basic unit. Then we understand the third power of, very careful understand, the third power of length is the volume. Am I correct? When it comes to area, the second power of length into length, L squared. The second power of length is area. So we understand how these basic units are involved when deriving a physical quantity, right? In a derived physical quantity, how the basic units are involved, we can get a clear understanding in example like area and volume, right? To get a more understanding how these basic units are involved in a derived physical quantity, we are using a concept called dimensions. Why we are using dimensions? If they ask you in the exam, they don't ask why we are using dimensions, why we are introducing dimensions for a physical quantity, to check, to get an idea how basic units are involved in a certain physical quantity. Do you understand? So then, since there are 7 basic units, write down. Okay, I will tell you the story. Okay, write down, write down like this. Write down. Write down like this. There are 7 basic units. There are 7 basic units in SI standard. In SI standard. Full stop. I'm not going to write what are those. Already you know. Next point, write down. Next point. Next point. All other physical quantities. All other physical quantities. All other physical quantities can be derived. Can be derived using above 7 basic units. Using above 7 basic units. If not using above 7 basic physical quantities, whatever. That same story. All other physical quantities can be derived using basic physical quantities, if not basic units. Right? Okay. Red color pen, write down. Red color pen. Red color pen, write down. Dimensions of a physical quantity. Dimensions of a physical quantity refers. Dimensions of a physical quantity refers the symbolic expression. The symbolic expression the symbolic expression the symbolic expression which gives the relationship between basic units, which gives the relationship between basic units the symbolic expression which gives the relationship between basic units where a certain physical quantity is derived.
where a certain physical quantity is derived. Where a certain physical quantity is derived. Full stop. Where a certain physical quantity is derived. Full stop. Right. Okay. Right. Look here. Right. Next point also take your super red color pen and write down. Super red color pen, very important point. Super red color pen, write down. Don't worry, I will explain the story. You don't worry. Super red color pen, write down. Generally, when writing dimensions of a certain physical quantity, generally, generally, when writing dimensions of a certain physical quantity, comma, they are written inside a square bracket. They are written inside a square bracket. They are written inside a square bracket. Highlight square bracket. Highlight square bracket. Right. Okay. Right. So already now I think you understood dimensions of a certain physical quantity means we are going to obtain a kind of a symbolic representation where these basic units are involved, how these basic units are involved when deriving a certain physical quantity. For an example, when you consider area, how basic units are involved when deriving that physical quantity area. So by using, we are defining some symbols. We are defining some symbols for basic units, and we are going to check what are the basic units, how are the basic units involved in a certain derived physical quantity. So you will understand more when I do like this. What we do, how many basic units we identified? There are 7. So we are giving a symbol. We are giving a symbol for each basic unit, right? So we all know. We all know, right? Mass. The first basic unit, mass, right? Then length, mass, length, then time. Next one is temperature, current, temperature. Very careful listen. This is a very important theory part. Temperature, current, luminance intensity, amount of matter. Luminance intensity, amount of matter. Luminous, luminous intensity, amount of matter. Right, these are 7 amount of matter. So one, the second one, 1, 2, 3, 4 or 5, 6, 7. Right. So what are we going to do is we are going to allocate. If not, we are going to provide a symbol to represent each basic unit, because every time writing mass with letters writing masses, LENGH is a kind of difficult story, right? So therefore, what are we going to do is we are going to allocate a symbol for each basic unit. Generally, 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 we are using the first capital letter of that basic unit as the symbol for that physical quantity. Right, I told you. So we are going to introduce a symbol for each basic unit.
Normally, that is the first letter of that basic unit normally, but there is a deviation. So we are introducing to represent mass basic unit. We are introducing to represent mass physical quantity. We are introducing capital M symbol. Capital M symbol. Now, don't you think meters? Meters means simple M. That is units. Forget about units entirely. Now we came to a different story, different chapter. I want to what? I want to represent mass using some symbols. Therefore, I'm using capital M to represent mass. Right? Capital M to represent mass. First letter also capital M. I'm using capital M to represent mass. Okay. So, the basic unit length, we can introduce capital L symbol to represent basic unit length. Capital T we can use to represent basic unit time. Capital M, capital T. Very careful in story. Yeah? Capital M, capital L. So you also try to use color pens as much as possible, because even I am using many color pens. To represent temperature, we are using our symbol as theta. We are using our symbol as theta. Our symbol is theta. To represent current, we are using our symbol as capital I. Capital I. To represent luminous intensity, we are using a symbol capital J. Amount of matter, we are using capital A. Capital A. Right. Okay. Now, what are we going to do in this lesson? Actually, we are going to find the dimensions of physical quantities. In your exam, they ask you, what is the dimensions of mass? What is the dimension of force? What is the dimension of acceleration? So you have idea already. Dimensions of a certain physical quantity means we are trying to obtain a symbolic expression of basic units involved to derive that specific physical quantity. For an example, when you are taking the force as an example, if they ask you in your exam, what is the dimensions of force? What are we doing there is, we are trying to derive a symbolic expression of basic units which involve to derive force. Do you understand? Then what have I done? I have done every basic unit. We defined a symbol MLT theta I J N. Right? Okay. Every time writing dimensions of is a headache. Right? If I ask you dimensions of mass, look here. Right? Dimensions of mass. Now you're writing what is the dimensions of mass? It's capital M only. Dimensions of mass, you would write down dimensions of mass capital M A S S. You want to write down dimensions of this word. You want to write this word completely. Dimensions of mass. Keep in your mind that is capital M. That is capital M. Right. Okay, I will come here. As I told, there are 7 basic units. So we are introducing a symbol to represent each basic unit. We are calling these symbols as the dimensions of these basic units. Do you understand? These symbols we call as the dimensions of these basic units. Am I correct? These symbols are the dimensions of these basic units. What is the dimensions of mass? If I ask you, capital M. What is the dimensions of length? Capital L. What is the dimensions of amount of matter? Capital N. What is the dimensions of current? Capital I. What is the dimensions of temperature? Capital theta. Theta. Very clear? So every time writing dimensions of mass, capital M, dimensions of time, dimensions of current, it's a headache. Writing dimensions of, and is also paining, very annoying to write again and again. Therefore, for our convenience, we are introducing a symbol to represent dimensions of as well. Rather than writing dimensions of, if you represent, okay, if you represent, look here very carefully. If you want to write, if you want to write dimensions of mass, if you write mass very carefully, if you write mass inside the square bracket, if you write mass inside the square bracket, then your teacher knows, the one who corrects the paper knows you meant a dimensions of, square bracket means, keep in your mind, a dimensions of, then only we are going inside the bracket. What is inside? Mass. Square bracket means dimension of, what is inside? Mass. Dimensions of mass. So when you represent by using a square bracket, we are representing dimensions of. Got it? So dimension of masses, we all know. Dimensions of masses, we all know that capital M. Right? So then keep in your mind hereafter, dimensions of means, we can use a small symbol. Dimensions of means a square bracket. Okay. Look here. Dimensions of means, you can use a square bracket. To represent dimensions of, you can use a square bracket. You can use a square bracket. Okay. So don't worry, when we practice questions, you will understand these stories. Square bracket. Square bracket. Hands up. Up to now, the story is very simple. Raise your hands. This story is very simple answer. If this story is very simple, every other story is also very simple. So what you do, by using a red color pen, you wrote something. So then what you do, first of all, write dimensions of black color, red color bracket, mention as square bracket, highlight this one. Okay, highlight this one. As an example, write this. As an example, dimensions of mass equal capital M. Put an arrow and write down. Rather than writing dimensions of mass by using letters, you can represent the same thing using the bracket also. Bracket means dimensions of mass. This one. So don't write this story. Yeah? Write this one. Example, this one, this one. Then I will come to here. Quickly write down and hands up once you finish writing. Now see, little by little, we are getting to the calculation part. Now not theory part. Huh? Little by little, we are going to the calculation part. Keep your focus. Physics is very interesting when you interestingly learn. Very interestingly learn. It's very question-based stories. Sometimes you want to think practically, right? Very nice lesson. So all the other lessons are learned by heart lessons, right? Most of the lessons we learn are learned by heart lessons, but this is a very practical lesson. If you can think, if you like to think, okay, it's okay. The way that you think can be a limited, but that can be improved. If you really like to think, if you really want to think, I will make you think, don't worry. If you like to think, this lesson going to be very interesting. Very interesting. When the recording of the session will be uploaded, now I will upload within 1 day, 2 day, I will upload it. Right. Finished writing. Hands up. Finished writing. Hands up. Right. Okay. Next point, write down. Next point. Therefore, dimensions of basic physical quantities. Therefore,
dimensions of basic physical quantities, dimensions of basic physical quantities, can be expressed as below. 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 Yes, we have class on Saturday. Last Saturday morning I didn't do because I'm planning to change that time. Saturday 7 a.m. Early in the morning. I'm planning to keep it a night time. I will confirm today, tomorrow, Friday night. I will confirm what is the plan for that accelerate A level. So you're going to start it. But as I told already, by the end of this month, now today it's 24th, 24th. So 24th. Yeah, early in the morning is a bit uncomfortable, right? Because when we do the class at night, it's very comfortable. Because early in the morning, want to wake up also, right? These days, since you are in your home, you don't like to wake up early in the morning. You like to sleep. I know that. Uh, in this case, now today it's 24th, May 1st, May 1st. So we'll have the exam on. We'll have the exam on May 4th. We'll have the exam on May 4th, right? May 4th. Sunday, because already on Sunday we are doing papers exams for 25 batch. I will keep the exam for 26 batch also on Sunday the same time parallelly. So you are also writing. You are also having the exam on the same time. Then 3 batches writing exams, 25, 26, and 27. Right? Okay. Right. Yes. So then what you do? Quickly write down these. But look here. Look here. Now you understood me. If you just write mass, the meaning is different. But when you write the mass inside a square bracket, when you write a mass inside a square bracket, then the meaning is dimensions of mass. If you just write mass, the meaning is something else. If you write MASSS inside a square bracket, then the meaning is dimensions of mass. So therefore, what you do hereafter, look here, what you do, put a square bracket. Put a square bracket. Then write on this 7. Dimensions of mass equals dimensions of length. But when you skip, when you don't write the bracket, then it's not dimensions, they don't give marks. Definitely you must put the bracket. Dimensions of time, dimensions of temperature, dimensions of current, dimensions of luminous intensity. Put the symbol equal. Dimensions of what? Amount of matter. Please use different colors: MLT red color, theta I J capital in blue color. There's a reason behind I'm saying. Follow what I say. Use some colors. Okay. Right, okay. So we'll do some examples. 10:30, 10:35 almost. I won't stop the class also. Right, okay. One last few points and look here. Right, okay. Very clear. So I understood what does it mean by dimensions of certain physical quantity. Yes, sir, very clear. That means so we are actually analyzing how basic units are involved in a certain derived physical quantity. I got it. That means sir, we are writing a symbolic expression for a derived unit in terms of basic units. Very clear. So we're writing a symbolic expression for a derived physical quantity in terms of basic units. Therefore, sir, we have to use some symbol to represent the basic units. Those are the dimensions of those basic units. For an example, dimensions of mass is capital M, dimensions of length is capital L. Yeah, very clear story, very clear, sir. But keep in your mind, in our syllabus, right? Yeah, we defined the dimensions for 7 basic units. But in our syllabus, we talk about dimensions of physical quantities come under Newtonian physics. Not Newton physics, Newtonian physics. Yes, we learned 7 basic units. Yes, we defined dimensions for 7 basic units. But remember, in our syllabus, we talk about dimensions of physical quantities which come under Newtonian physics. When it comes to Newtonian physics, keep in your mind only 3 basic units involved in Newtonian physics. Only 3 basic units involved in Newtonian physics, that is mass, length, and time. Hereafter, we are deriving, we are learning dimensions of physical quantities come under Newtonian physics. So therefore, remember, even though we don't talk these stories much, we are talking physical quantities which come under Newtonian physical quantities which come under Newtonian physics. Keep in your mind, mass, length, and time are the physical quantities come under Newtonian physics. Because we are learning Newtonian physics, therefore we are considering Newtonian physics dimensions. Dimensions. So what you do? Write down. This is Newtonian physics dimensions. Newtonian physics physical quantities. The physical quantities, write down like this physical quantities in the story. Write down. Red color pen. Red color pen. In the Newtonian physics. In the Newtonian physics, comma, mass, comma, length, and the time are dominant. If not, we can write down. Okay, yeah. In the Newtonian physics, mass, comma, length, and the time are dominant. Full stop. Continue. Okay, write down. Continue. Mass, comma, length, and time are main 3 measurements in the Newtonian physics. Mass, length, time are main 3 measurements of physical quantities in the Newtonian physics. Right? In the Newtonian physics. In the Newtonian physics. Right? Okay. Okay. Next point, write down. 1036. Next point, write down. Hereafter, all the dimensions of physical quantities are hereafter. All the dimensions of physical quantities are hereafter. All the dimensions of physical quantities are represented based on hereafter all the dimensions of physical quantities are represented based on dimensions of mass, comma, length, and time. Hereafter all the dimensions of physical quantities are represented based on dimensions of mass, comma, length, and time. Finished. That's it. Genuinely hands up. Up to now, everything is very clear. Then we can do 2 examples and we can stop the class today. Genuinely hands up. Dimensions part, it's a bit critical part, not difficult, right? Even though I say that it's complex means not difficult. Complex means there are many points to be remember, right? But don't worry, I am there to explain like a very simple manner. Keep your focus. Hands up no story is very clear, very simple. Everything is okay. Okay. For an example, now we'll find the dimensions of, for an example, what is your favorite physical quantity? Just put the replies. Put in the chat. Put in the chat. Tell me your favorite physical quantity so far. Reply everyone quickly. So don't please go with the basic. Yeah, I know that you like the basic physical quantities. Sometimes you may like mass. I really appreciate. But apart from these 7, please come up with different physical quantities that you like quickly. Quickly. Acceleration, okay? We'll start from a bit easier one. Momentum also okay. Momentum also okay, right? The momentum, if I ask what is the equation of momentum, can you remember? We start from a bit easier one. Okay, area. Yes, very good area. As you told, we'll go with the area. Now, how are you going to find the dimensions of area? Look here. Example. Example. This is how we are going to find the dimensions of physical quantities. Right? Example 1. X1. Area means we all can remember. Area means we know the equation. Better you write the equation. Area means we know length into width. We all know. Okay, force also good. I will do the force also. We all know area means we all know length into width. This is the equation. We all know. This is very basic equation. What's your goal? My goal is to find the dimensions of area. If you just write area, that's a different story. If you want to find dimensions of area, you want to write area inside a square bracket. You want to write the area inside a square bracket. Then again I am writing, look here. Again I am writing like this. Again I am writing, look here. Area, okay, area, look here. Area, length into width, look here. Look here. Since I want to find the dimensions of area, write down area inside a square bracket. This is an equation. If you don't write area inside a square bracket, it's an equation. But if you write this area, then when you write area in the square bracket, you want to write remaining physical quantities also in the square bracket. So dimensions of area, red color one is dimensions of, inside area is there, then its dimensions of area equals dimensions of length into dimensions of width. Am I correct? And now we all know that dimensions of length means I already defined. Dimensions of length equals to capital L. It's capital L into dimensions of width. Width is a length, then length dimension. Length dimension is capital L. Again capital L. Finally, we can write down L into L means L squared. So keep in your mind, dimensions of area means L squared. Dimensions of area means L squared. Finally, area dimensions means L squared. Clear, right? Clear. Right. So volume, okay, right. Okay. Today I'm ending with this example. Right? Time is almost 10:45, almost in 45. Genuinely hands up. Now, but you don't want to keep any doubt regarding my teaching skills. You don't want to keep any doubts regarding my teaching skills. Can understand, right? So when you go to my YouTube videos, you can compare it. So in YouTube videos, you can see many teachers' videos. Along with that, please compare how the way that I am teaching. You don't want to keep in doubts with the way I teach. I know who I am, right? Genuinely hands up. Today's theory, crystal clear. Hands up. Crystal clear. Class is very effective. Hands up. Today class is very effective, sir. For me, it's very effective. Okay. So then the last few points. Next day we are doing entirely dimensions, right? Next Thursday we are doing entire dimensions, and fourth we'll have a exam which comes from units and dimensions only. Study, prepare short notes. Upcoming days I will teach you how to prepare a short note, and after 3-4 months later I will give you some work plans also, right? Don't worry. Okay. So now I want to start that accelerate A level session, right? Where I discuss some simplification stories. I will give you the detail. Don't worry. Please, you don't worry. I posted the tunes. You will get them. You don't worry. Definitely will get them. Don't worry. Right? Wait until next Monday. If you didn't receive even on Monday, then I will tell you one point. Please check with that. If not, I will post the tunes again also. I have no issue with that. Okay, right. That story is okay. So now day by day, 1 month is almost finished because you started doing A levels in this month, say April beginning. Now this is the last week of April. So likewise, keep in your mind this time runs like a butterfly. Time is running so fast, right? Sometimes we don't even feel that the time is passing. So therefore, from now onwards, start working. Don't compare your friends. Don't always try to go with your friend's path. Please don't. Now you are an A-level adult, you are an adult student. So therefore, don't always prefer your other friends' decisions. If you think something is really suitable for you, follow that, right? That is the my important point. Select good classes, select proper classes for all three subjects. Don't go behind the popularity. Don't go behind your teachers are beautiful or smart or whatever. Don't go behind your teachers are rich or your teachers are whatever. Please don't go behind your teachers giving fun entertainment. Please, you are an A-level math science students. Your goal is not to take fun after A levels. Your goal is to serve people. If you are becoming a doctor, your goal is to serve people. Serving people can become kind of fun if you love and if you do it, but serving people is not a fun thing. Becoming an engineer and doing projects is not a fun thing. If you're really interested, it can be kind of fun. It gives kind of fun to you, but becoming engineers are not fun thing, right? We've learned now we are doing A levels not to do fun things. We are enjoying while becoming a doctor or while becoming an engineer. But if you're expecting fun, if you want to do fun, if you're expecting fun from A level classes, better you go for arts classes, commerce classes. That is much suitable for you. 2 hour classes, 1.5 hour classes, 1.5 hour, half-an-hour interval, 1 hour gossip story, girl jumped, boy jumped, girl and boy affair, whatever. Story class finished. Only half-an-hour teaching. A math science, we are not doing like that. Now, see, you can understand how I have conducted online. This is my fourth class. This is my fourth class. Day one in my YouTube, day one I uploaded. I talked fully gossip stories. Day two started theory, not that much. Day three did much theory. Day four, you understand. This is my teaching pattern. This is my teaching pattern. Right, okay. We'll meet on next day. See you. Bye. Have another class at 11 p.m. 25 people. Right. See you. Have a nice day. Bye.